Welcome back to the exciting conclusion of chapter 1.4. So we're starting with domain of functions. Now remember, the domain is the set of inputs, so it's all the x values. So, and domain can be described either explicitly or implicitly. An implied domain is a set of all real numbers for which the expression is defined. So it would be all real numbers except for two exceptions here. So you have to exclude values that would cause division by zero, because division by zero makes it undefined. Not allowed to do that. Or exclude values that result in the even root of a negative number, because you cannot take the even root of a negative number that's not a real number, that's an imaginary number. And we're concerned with real numbers here, finding domain. So that's our success criteria, basically. Domain is all the reals except for this case, division by zero, or getting an imaginary number by taking the even root of a negative number. So let's go through these four examples together. So that's the learning target. I can find the domain of a function. So the first function is 3x squared minus 7x plus 4. So I'm going to check. Does this have division by zero? No. Is it taking the even root? No, there's no roots there. So the answer would be all the reals. And that's it. That's the sign, the symbol for all the reals. All the reals. Okay. All right, so let's look at 18. So this is going to be all the reals except division by zero. There is a case where this could be divided by zero. And to find that case, what I'm going to do is I'm going to take the denominator, set it equal to 0, and see what does x equal to get that 0. So this needs to be factored. I'll take out an x, and I'll have x minus 7. So then x equals 0 and x equals 7. So if x is 0, you get a 0 denominator. 0 minus 0 is 0. That's not going to work. If x is 7, you would have x squared, which is 49, minus 7 times 7, 49. That gives you a 0. So all the reals except x cannot be 0, x cannot be 7. Okay? Those are the exceptions to the domain. All right. Let's look at a root one. So remember this case, even root. Even root. This is a square root, so that's a 2. That is an even number. So we need to test for that value. So I'm going to take what's inside here, and this has to be greater than or equal to 0, because anything less than 0 gives me a negative number. That's an imaginary. It's not going to work out. So I'm just going to solve for x here. Subtract 6. Divide by negative 2. Remember, when you divide by a negative, you need to flip the sign. So my domain is x less than or equal to 3. So that would be all the numbers from negative infinity up to 3. And that would be the domain. Okay? Now this one, this is a cubed root. That's an odd root. So that's easy. All the reals. Done. Okay, moving on to applications. All right, we have 3 applications here, 3 story problems to go over. All right, 21. You work in a marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. And that's given right here. So height over radius equals 4. Write the volume of the can as a function of the radius r. Well, first of all, I need to know the formula for volume. Volume here. V equals pi r squared times height. So that's helpful to know. And then if I want to write it as a function of r, that would be V of r. So it has to be everything in terms of r. So I need to replace this h with an equivalent in terms of r. So what I can do is solve for h here. If I solve for h, I would just multiply both sides by r. So h equals 4r. And now I can say pi r squared, instead of h, put it in terms of r, h is the same as 4r. So times 4r there. And then you would just simplify that down, and that would be 4 pi r cubed. And that would be the answer. Now I want to write it in terms of height. So v of h. So now I need to solve for r. So I can just use this, get r by itself. I would just divide by 4. R equals h over 4. So pi, replace r in terms of h, so h over 4 squared, r squared, and then times h. And then simplify that. This would be h squared over 16. When you times it by itself. And then multiply straight across, I would get pi h cubed over 16. And then that would be the answer. All right, next one. A batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. Using all that information, we come up with that function right there. And f of x is the height of the baseball in feet. So this is the height of the baseball. And x is the horizontal distance from home plate. Right there. Will the baseball clear a 10-foot fence located 300 feet from home plate? That is important right there. That is x, the horizontal distance. It's 300 feet away. All right, so I'm going to plug in 300 for x here. Then I'm just going to simplify that all out. And I get 15. So f of x equals 15. And remember, f of x is, where did it say that? F of x is the height of the baseball. So my baseball is 15 feet, okay? And the question is, will it clear a 10-foot fence? Well, yeah, it's going to clear it by 5 feet. So the answer is yes. It will clear the 10-foot fence. Okay? All right, you try 23. It's the same as 22, and then check your answer with the key. And that is a conclusion of 1.4. Oh my goodness, I did not even show you that answer. Okay, bye.